Hello, my several viewers. Today I'm making a tool that I hope is going to help with the clamshell bucket project. It's a little bit different, and I thought I would show part of how I'm making it, show you the drawing I made of it, and see if you can guess what it's going to be used for. This is the drawing. It's pretty crude, but it's good enough for what I need to do. You can see it's got it's a shaft, a few different step diameters on it. It has some flats milled into it once it's done, and it has a thread on each end. At the one end is a 1" 8" thread. At the other end is a 1½ 18" thread. Some of you guys might know what those threads are used for on machine tools. And you may be able to guess what I'm going to do with it, but I think I'll show some steps in making it, and then at the end I will use it essentially, and you'll see what it's for. Anyways, I hope you enjoy watching this. I've already roughed the part down. It's a piece of 4340 heat treated stress relieved. This is my favorite material to machine. It's very strong, it's relatively hard, it machines nice, you get beautiful finishes, and you don't get little nicks and dents from accidentally bumping it because it's hard enough that it resists that. It's a great steel for making tools out of, and also for things like pins and other items that are going to receive shock loading. It's a great material for that. I roughed it down. I finished these diameters up to here, and I was just about to cut the thread. I thought I'd show some of the thread cutting. Now, I was going by memory for the minor diameter of a 1" 8 thread, external. I thought it was 7/8, but I think that might be the minor diameter of an internal 1" 8 thread, which would be the tap drill size. I think that might be what I'm remembering. So we'll have to look in the Bible and see what it says. And what do we have? 1" 8, and this first section is external threads. And if we look over here, minor diameter, about 850, so it's 25 thou less than I thought it was, so that would explain why I'm not deep enough. So we'll keep going. Oh, it's a nice fit. Almost no slop and it turns easy, but I want, for what it's gonna do, I don't know if I want it to be that close. Might take one more spring pass. Just open it up a little bit. That should do it. Yeah, it's got a little bit of slop. Goes on nice, not too loose. I think that's going to be good enough. Now that the all the turning work has been done on this tool, and I've got the thread on this end, 1" and the 1.5 18 on this end, it's time to put flats in. And I'm just going to change the design a little bit. I was going to set them off to one side, but I think I'm just going to put them right down the middle. I've put this 1" nut on and tightened it slightly. And that's just going to give me the ability to index this using a square. So I can just turn it 180 and mill the flat on the other side. It's a quick way for when your indexing doesn't have to be really precise. It just saves me from having to set up the dividing head. So I didn't record it, but I came in and touched both sides of the center finder and used the half function on my readouts to find halfway between here. And I just got to touch the end mill on here, and then I have to go down, I believe it's 162.5 thou. And that'll be the depth of the flat, and then when I rotate it around, I'll do the same thing, and when I'm done, they should be 1 5/8 across the flats. I'm milling this out with a 1/2 inch end mill, so the slot it's cutting right now is 1/2 inch wide. I want to go about 60 thou wider than that to fit the wrench. So what I'll do is I'll take the depth to within about 10 thou, the finished depth. Then I'll take a 30 thou offset on each side, and then I'll take final pass at the correct depth and width. In fact, I won't take a 30 thou offset, I'll take about a 25 thou offset, and I'll take a 30 for the final. So I'm gonna go about 150 on here for depth. I'll go over about 25 thou. Back 25 the other way. it's essentially roughed out. I got about 5 thou on each side to go and 10 thou on the bottom. So I'll raise the table up. 162.5. Over 30. Back 30 the other way. And that should be this one side done. Wrench. Yeah. You can see there's lots of play on each side, so it'll be good. That's the first flat on the one side. Now I have to rotate this 180. Now I may have outsmarted myself here. I set the nut up on this end so I can index this 180, but I made no provision for control in the axial direction. I could just rotate it and pick up either side again, but I think what I'll do instead is I'll just put an indicator on the end, zero it, and make sure I get it back where it was at the beginning. Okay. Good. We're at 0 on the indicator, and you can see we're lined up on the hex. So we should be indexed and in the axial position correctly. That's it. Let's blow it off and check the fit on the wrench. Oh, that's typical. That's good. Good fit. Earlier in this video I'd mentioned that I like making tools out of 4340, and I think this probably shows why. It turned out really nice. The surface finish is nice. It's hard. Not hard like a piece of high-speed steel, but much harder than mild steel, so it stands up to dings from wrenches and things like that. So it makes really nice tools. 4340 heat-treated stress relieved. Now, what is it used for? Now this is the setup I've come up with to bore the holes in the pin boss plates after everything is welded together. I've just drawn the holes in marker. You can see here, and on the back side the same. And we know that this hole and this hole have to be perfectly in line because a pin is going to pass from one to the other. The setup I've come up with is to turn the head on my boring machine, on my my milling machine, to the side, and then I can, it's obviously turning slow, but I'll be able to just feed into the hole and bore it to size, and then I'll be able to move into the next hole and then feed in it as well. Now, the nice thing about this setup is it allows me to mount it rigidly to the table. I'm not up on a rotary table, which was my original idea, which could be kind of flimsy. The table isn't overhanging. There's very little travel required to bore the hole, so it's a nice, solid, kind of robust setup. What I thought I might do is bore this hole out, bore that hole out, and then rotate the head 180 degrees and bore these ones out. But I'm not sure if the axis of this spindle coincides with the axis of rotation of the head, and if it doesn't, then one side is going to be higher than the other. So I was trying to figure out how I could get around that problem, and that's where the mystery tool comes in. After I'm done boring the holes on this side, what I can do now, this would be installed already, but the tool is simply a drawbar with threads on the end. And some of you may have picked up on the thread size and know that a 1.5 18-inch thread is the standard thread for mounting a Criterion style boring head. So essentially what I've done is made a drawbar that allows me to mount the boring head on either side of the milling head. So after I've bored the holes out on the left side, I can remove the boring head and reinstall it on this side. Then I have to run the spindle in reverse. But I'm now able to be able to come up and bore the holes on that side. Now, I have digital readouts, so I can accurately place the table back to where it was when I bored the holes on the left side. And although I've changed the boring head from one side to the other, and the threads may be slightly different, the axis of rotation is unchanged. So it should bore a hole on this side perfectly in line with the hole on this side, which is exactly what I want. It'll be similar to line boring, but without having to use long boring bars. So this will be in a future video. I will bore the holes out on the pin boss plates. But that was the purpose of the mystery tool, was to just allow me to put the boring head on either side of the milling head so I can access the holes on either side. Thanks for watching.